के पढ्न खोजेको सिक्वेन्स एन्ड सिरिज हैन ओके ल sequence and series. First, in school level we have two types of sequence. There is two types of sequence. First one is arithmetic sequence, and second one is geometric sequence. This one is arithmetic. Generally you can apply ARITH. So in two sequence, first arithmetic sequence depend upon the ratio between two terms, the difference between two terms, and geometric be ratio between two terms. The two terms हामी जब रेशियो निकाल्छौं त दिमागमा यो राख्नु पर्यो पहिला सबभन्दा पहिला कुरा कि रेशियो सिक्वेन्स को प्याटर्न को आधारले जाने त यो हामी पहिला पनि गरेको ठीक छ So arithmetic वालामा हामी T1, T2, T3 so up to Tn, and similarly T1, T2, T3 and so on. So in this term, if difference is we have to find, then we have to go for T2 minus T1 always equal to T3 minus T2 always equal to T4 minus T3 and so on, Tn minus Tn minus 1. Okay, so this is the actually which we got from the sequence two terms of the sequence difference. Okay, for arithmetic series, and similarly for the geometric series we have to go for the ratio. So ratio can be obtained by dividing T2 by T1. Similarly it will T3 by T2 and dot Tn by Tn minus 1. Okay, so in this sequence first we go for the difference arithmetic pattern, second we go for the ratio geometric series geometric pattern. So in geometric and T1 arithmetic series, now the formula is go for, so first term T1 is supposed to be a okay, T1 is supposed to be a, then T2 becomes a plus d, then only you can got d is equal to T2 minus T1. So a plus d minus a is becomes a d. Okay, similarly you go for the third term T3, it will a plus d and plus d, it becomes a plus 2d. Similarly for T4, a plus 3d. Similarly dot up to Tn, you will receive a plus n minus 1 times d, which is the general term of the arithmetic sequence. General term, it means nth term of the arithmetic sequence. So in arithmetic sequence, this one Tn is called sometime B, sometimes L. ठीक sir. So L, B and Tn be the same thing according to the question. Okay, sometimes we need a B, then we go for the B is equal to a plus n minus 1 into d. Sometimes we go for the L, and L is equal to a plus n minus 1 into d. So in this way you will get the general term of the arithmetic sequence. Similarly you have a geometric sequence. In geometric sequence there is also a same type. T1 is a, okay, T2 becomes a into r. Okay, then only be possible our ratio is equal to T2 by T1, and it becomes AR divided by A, it becomes R. Okay, in this way T3 becomes T2 into R, that is AR square. Similarly T4 ARQ, and then go on for Tn, it becomes AR to the power n minus 1. Similarly, this general term for geometric sequence, and geometric sequence, similarly you can use B as a Tn, sometimes L as a Tn. Okay, for next one, so this one arithmetic, for arithmetic series, Sn is equal to sum of the nth term, first n terms, generally sum of first n terms, and it becomes a plus n by 2 into 2a plus n minus 1 into d. Okay, so this one, and after the detecting this term between this a and a plus n minus 1 into d, it becomes directly the nth term of the series, which we discussed in previous, that we can use n by 2 and a plus L or B or Tn. Okay, in this way. So Sn, sum of first n term of the arithmetic sequence, it becomes n by 2 into a plus L, or n by 2 into a plus B, n by 2 into a plus Tn, in this way. Similarly, for geometric series, sum of nth term of the geometric pattern, geometric number, the geometric sequence, it becomes a into n minus L r minus 1 by Rn, actually Rn minus 1 by r minus 1. And if only be possible when r must be greater than 1. If r is lesser than 1, it be changed, a into 1 minus r to the power n and divided by 1 minus r, if r is lesser than 1. But this is very rare case, and this will not mostly usable in up to 10 class. Okay, so this be mostly usable, a into Rn minus 1 by r minus 1. So this term, how can you get when the last term is given? Okay, so for this you can use a into Arn minus a and divided by r minus 1. So calculate this one, Arn minus 1 into r minus a divided by r minus 1, and this Arn minus 1 become a last term of the previous, which we discussed already. So this become a b or Tn or L r minus a divided by r minus 1, or simply L r minus a divided by r minus 1 is a sum of first nth term of the geometric sequence, geometric series. Okay, so in this way we can deal with the sum of the first n terms of arithmetic and geometric. And we go for the example also. Okay, so this one is accept the mean between the a and b. Okay, and this one we have to discuss this one also. So mean of the geometric and arithmetic series. Okay, mean. So for the mean of arithmetic and geometric series, we go for if a and b be the first and last term of the series, then there is a n mean between a and b. N n mean between A and B. So if A and B is a first and last term, this one is first term T1, this one is Tn. It means here n means number of term. Okay, so the n becomes a number of term and this becomes T1 to Tn. So this n is equal to what? There are how many terms? So this n notified number of term is equal to this one. Suppose this one supposed to be a n1, okay, and n1 is equal to number of mean plus first and last included as 2. So n plus 2 term between A and B. So in this way A and B is a first and last, and then you go for the first mean, and first mean is started from second term. This one is first mean, T3 becomes a second mean, this one is second mean, T4 become a third mean, M3, and in this way you can go for the Tn minus 1 become a nth mean of the series Tn, okay, and then Tn is the last term and this become a B. So in this way A and B cover all elements between M1 to Mn. M1 to Mn is the mean between A and B, and M1, what is the formula of M1? The M1 formula is equal to the formula of T2. M2 formula is equal to the formula of T3. In this way Mn formula is equal to the formula of Tn minus 1. So in this way we can use A plus D, A plus 2D, A plus n D, where n is a number of mean, because there is we use n dash little bit separate than the number of mean, and we can use the number of mean between A and B. So this one is work for the arithmetic in this way, and if we go for the geometric, it becomes AR. This one is arithmetic sequence and this one is geometric sequence AR. This become AR square AR to the power n. So the both combination be folded for arithmetic and geometric sequence and geometric series. Okay, so this is very easy, I think. Okay, and the next term which we discussing about, if B is equal to A plus n minus 1 into D, where n is a number of term for arithmetic series, then if we go for the number of mean between this, then n is replaced by n plus 2, because n1 is a stand for the number of terms. Then we can use A plus n plus 2 minus 1. This one supposed to be n1, and then it become D, and it here n is a number of mean between A and B, number of mean between A and B. Then D is equal to what? B minus A divided by n plus 1, where n is a number of mean between A and B. Similarly, you can go for R. B is equal to, in this one is AS for arithmetic sequence, this one is geometric sequence, and B is equal to what? B is equal to AR to the power n minus 1. This one n become a number of terms, and then you can use AR and n plus 2 minus 1. This one n is number of mean between A and B, then you can apply B by A is equal to R to the power n plus 1, and R is equal to B by A to the power 1 by n plus 1. So this one is the most important formula. This one is also most important formula for mean, including mean between A and B. And this one is you can use for a geometric pattern. This one AR, AR square, AR n, and A plus T, A plus 2D, A plus ND with the for arithmetic sequence. So